Can you tell me if the board is clear or not? Can you tell me whether the board is clear or not? Okay. Is the board okay today?
Yes, sir.
Okay. Okay, so we are talking about finding eigenvalues, right? So last time what we did is we first talked about a method which is called power method to compute the largest sized eigenvalue of a matrix, and then we see something called Rayleigh quotient, which is basically another way of finding the largest eigenvalue, which in fact increases the rate of convergence in the power method. And then we see a process called deflation process, right, which by which you reduce the matrix into one size less matrix after doing the first step of after finishing the first round of power method, right? So you reduce the matrix into an n-1 plus n-1 matrix, and then you apply the power method again to get the second largest eigenvalue, and you continue that process to compute all possible eigenvalues. Right? So that is called deflation process. So now what we are going to do is we are going to see an improvement technique which is used to improve the computation, the computed eigenvalue which is computed by the power method. Right? So this is called inverse iteration. And so this one is called inverse iteration. So here, what we are going to do is first we will see, right? So let lambda 1 up to lambda n be the eigenvalues. Okay, let A be a matrix, and then lambda 1 up to lambda n be the eigenvalues of the matrix, right? So then right, for some rho which is a constant value, right? So let us assume that this constant. Okay, so for some constant value rho, right, the eigenvalues of the matrix A minus rho I, right, such that, so you choose rho such that the inverse of this matrix exists, right? So if rho is equal to one of these lambda 1 up to lambda n, then you know that the inverse cannot exist, right? So in that case, right, so you can see that whenever the inverse of the matrix A minus rho I exists, then the eigenvalues of these matrices are A minus 1 upon lambda 1 minus rho, 1 upon lambda 2 minus rho, and so on. Right? So you can easily see that. Right? So because you know AI Zi is equal to lambda I Zi, right? So you know, so A Zi, so A minus rho I Zi is equal to lambda I minus rho times Zi. So you subtract rho times IZI from both, so you get this. Right? So if you rearrange this, 1 upon lambda I minus rho times Zi is equal to A minus rho I inverse. And so because of this argument, you see that the eigenvalues of the matrix A minus rho I inverse are 1 upon lambda I minus rho. So what we are doing is we can apply the inverse equation for this A minus rho I matrix, right? So right, so let us apply our method to the matrix A minus rho I inverse. Right? So that will help you to find the largest eigenvalue of A minus rho I. Right? So let us see the power method. So here again, right? So this is going to be the power method when you apply, right? Power method applied to A minus rho inverse I, right? So this is the power method for this matrix. So this power method, right, has a special name. This is called inverse iteration. Okay, so this power method applied to this inverse matrix A minus rho I is called inverse iteration. Right, so this is called inverse iteration. So again, right, so you know that the same procedure which we applied for power method will work for inverse iteration as well. Right? So let us assume that. Right, so let us assume that the eigenvalues of the matrix, right? So just say we will say this one is larger. And so first condition, let us assume that the eigenvalues lambda minus rho are arranged in this order. Right? So you know 1 upon lambda 1 minus rho is the largest eigenvalue. then 1 upon lambda 2 minus rho, and then all the way up to lambda n minus rho. Right? So you can always rearrange that. Right? Right, so suppose that the initial value, right, component of Z1, right, Z1 is the right. We have some power failure here.